In this section, we'll look at GPS and surveying and comment on some of the traditional methods of surveying as well as the role of GPS in land surveying. In surveying, surveyors measure horizontal positions and they're recorded in either geographic coordinate systems or plane coordinate systems. Control points are used as well as benchmarks to understand location fixes. The National Geodetic Survey has identified 4 orders of control point accuracy, with a range of 3 millimeters to 5 centimeters maximum base error, which is allowed. It's quite accurate. National Spatial Reference System includes 300,000 horizontal and 600,000 control stations. These control stations and horizontal stations are then used to further locate points. This is an example of a benchmark used to mark a vertical control point. Limitations of using a magnetic compass in comparison with other methods are that true geographic north and magnetic north are in different positions. Magnetic north also varies over time, and rocks may affect magnetism. So surveyors over time have looked for alternatives to compass readings. One of those is the transit. A transit is a telescope used to sight distant target objects. 2 measurement wheels, similar to protractors, are used to measure horizontal and vertical angles. Bubble levels are looked at as well to maintain a true perspective. Following the use of transits, theodolites were invented, which gave better precision and include electronic instruments. Here's an example of a traditional transit once used by surveyors. Angle measurements include azimuths and bearings. Azimuths range between 0 degrees and 360 degrees and are measured clockwise from north. Bearings include angles less than 90 degrees, are measured within a quadrant, and are defined by cardinal directions. For example, south 45 degrees and 135 degrees are in the same direction. Here's an example that compares the two. Compass bearings are on the right and azimuths on the left. So notice, for example, north 45 degrees east shows you that angle is halfway between north and east, whereas 45 degrees in an azimuth shows you simply that it is 45 degrees away from 0. In measuring distances, metal tapes in 100-foot lengths were used prior to the 1980s. Electronic distant measurement replaced tape starting in the 1980s. This allowed more accurate measurements to be taken. It allowed greater flexibility for surveyors working in the field as well. Total stations include both EDM functions and theodolite functions, and they're commonly in use by surveyors today. Here's an example of a surveying team measuring a baseline distance with a metal tape in 1916. Here's an example of a modern total station. Angles and distances are used to determine positions. Horizontal positions are located relative to either the equator and the prime meridian or to a local XY axis on a plane coordinate system. A traverse can be collected through either an open traverse or a closed traverse. The process of triangulation is used to extend and add density to horizontal control networks. So, for example, in order to create triangulation, to take a triangulated point, first of all, an azimuth, in this case alpha, and the baseline distance AB are measured. The position B is calculated in an open traverse. The surveyors then measure the interior angles CAB, ABC, and BCA at the point of A, B, and C, and then calculate the length of the other side. The position C is then fixed. Length of side BC is calculated, and this is used as a baseline for triangle BDC. Triangulation is thus used to extend control points point by point and triangle by triangle. So additional unknown positions can become known positions through the use of triangulation. Trilateration is another way of using distances to find location. Trilateration uses a distance from a control point to determine the position by using an open traverse from a known distance. A circle is then used to confine possible points along the circle. Then, with the introduction of a second control point, the possible answer points are reduced to 2. Add a third point and the circle may then identify the true position. And this concludes the lecture slides for Chapter 5.